Okay, problem number 43. We're dealing with RL circuits now. Okay, so we're given an inductor, a resistor, and a battery, right, hooked up to a circuit, and there's a switch. So we have an open switch. We're going to close it, and some stuff is going to happen. We're told the values of these. This is 12 henries, this is 4.5 ohms, and this is 24 ohms. The first thing we're asked to find is, part A, we're asked to find I max, the current max, maximum current. What can we maximally have? Well, we're going to have the battery. So as soon as the switch closes, we have 24 volts, right? And then we have, so let's recall E equals IR. And this would be maximum, right? So this is max, and this is going to be R. Why is it max? Because this is going to be the full EMF. So then we take E over R is equal to I maximum is equal to 24 volts over 4.5 ohms is equal to, let's fix that. What do we get? We get 5.33 amps. Okay, next we want to find time constant. So we have this relationship, time constant times the resistance is equal to the inductance. We know L and we know R, so all we have to do is plug in. L over R is equal to 12 henries over 4.5 ohms is equal to 2.67 seconds. Okay. Then we're asked to find the time that it took for a current to get to 95% of the maximum current. So we would say I is going to be times I max, right? Okay, and we have this relationship that we've seen before. So I is going to be equal to I max. This formula is also in the summary. And so we have 1 minus E negative T over the time constant. Okay, and we want to find the time. We also are going to use our time constant. So we really just have to solve for T here and plug in some things. Okay, so we'll take I max to the other side. 0.95 I max over I max, so those cancel. All right, is equal to 1 minus E to negative T over tau. So we'll take this term to the other side, and we'll take this term to the other side. So that's going to give us E to the negative T over tau is equal to 1 minus 0.95. Right? Then we take the natural logarithm of both sides. And we end up with negative T over tau is equal to the natural log of 1 minus 0.95. Excuse me. Sorry. We're solving for T. We know what tau is. So then we let's see, where are we? Here we go. T is equal to negative tau times ln 1 minus 0.95. So we can plug this. This is 2.67 seconds, by the way. So we plug this into a calculator, and we end up with 7.998 seconds, 8 seconds. That's the time we're looking for. All right, problem number 45. We're given the same circuit, same thing, but we're told that the values are different. So in this one, we have EMF of 9 volts. We're told that a current is going to be 1 amp, and the maximum current is 2 amps. Then we're told that passing time is 0.1 seconds. Okay. we are asked to find the time constant for all of these values. And so we use the same formula that we did before, 1 minus e to the negative t over tau, because we know everything else, right? We know I max I, we know t. So doing the same thing I did before, we solve. So yeah, I guess I'll just do this. 1/2 is equal to 1 minus e negative t over tau. I'll just quickly go through it. Take this to the other side, take this to the other side. We end up with negative t over tau exponent, and then this is going to be 1/2. Take the natural logarithm of both sides. That gives you negative t over tau is equal to ln 1/2. And we're trying to solve for tau, so we put this on the other side. Well, yeah, do this and this, right? Negative t over ln 1/2 equals tau. And so we plug in the value for t, which is 0.1 seconds, and this gives us a value of 0.144 seconds. Okay, part B. We are asked to find the EMF across the inductor at two different times, t equals 0 and t equals 1 second. T equals, oops, sorry, not 1 second, it's 0.1 seconds. Okay, so we have some relationships that we can use. Let's recall that for a resistor, we have delta V is equal to IR, which is also equal to, now in this case, EMF times 1 minus e to the negative t over tau. Okay, and then using Kirchhoff's rules, we have E minus delta VR, which if we plug it in, right, so yeah, that's right. Sorry, I made a mistake. What was it? E1 minus E negative t over tau. That's what it is. Okay, good. And then this gives us actually, this term will cancel, this one will go positive, and then we'll still be left with the EMF t over tau. This is going to be VL. That's what we get. Okay, so really all we have to do is take this, so you highlight this, take this, and take this, and then we just plug in the values for t to find these. Okay, so we need to recall that we have this relationship, which is where we pulled some of these from. And then so once we find the values for these two things, we can figure out the total EMF, right? So at time 0, this is equal to 0 because we're going to have 1, because we have 1, and this term goes 0 to e to the 0. To be more explicit, I'll just show you what I mean. E to the 0 equals 1 minus 1, e equals 0. Okay, great. Next, delta V at 0.1. And the EMF, remember, was 9 volts, and we had 1 minus e negative 0.1 over 0.14, is that 0.144 seconds. Okay? Oh, we're asked to find the, just for the inductor, that's what I was saying. So we don't even need to worry about this one. So, okay. So just considering this, then, delta VL is equal to the EMF times 0, exponent to 0 is equal to the EMF, which is 9 volts. At time 0, it's 9 volts. Then we have 9 volts times e to the negative 1 over 0.144. So this comes out to 4.49 volts.